Hello, it's early summer 2025, and people are talking about the solar maximum, how it's lighting up the sky with aurorae, even here in Oshawa. You might wonder, why is the sky glowing? A bit of research points to solar flares. Unlike the Earth, the Sun isn't solid. It's made of plasma. It rotates faster at the equator and slower at the poles. The magnetic field twists and tangles. The result? Solar flares and prominences, bursts of energy that are flung into space. This behavior isn't unique. Fluids under uneven energy gradients often form dynamic structured patterns. We see this in storm formation and ocean currents. On the Sun, an uneven magnetic field results in an 11-year sunspot activity cycle. Sunspots are regions in the Sun where the Sun's magnetic field is so twisted it traps heat and blocks convection. But even within these suppressed, chaotic regions, tiny bursts of heat and light still break through. These are called umbral dots. A mathematician might refer to these as stable solutions. The key insight here is that even in chaos, we sometimes find stability. My work with Professor Greg Lewis this summer has been to study the nature of this stability in our own electroconvective system and then relate that to what we observe in sunspots and umbral dots. We start with a ring of fluid. The inner ring is rotating and has an electric charge applied to it, while the outside is not rotating and it doesn't have a charge. This creates a gradient, much like the Sun's differential rotation and internal heating. At first, we see 6 counter-rotating vortices, a metastable state, but over time these vortices fluctuate and merge to form one single vortex that's stable. This transition mirrors how there's umbral dots popping up in sunspots. Our data suggests that the stability happens because the electric field separates into a positive and a negative hemisphere. Could the same be the cause of umbral dots in sunspots? It's easier to relate our electroconvective system to a sunspot and our stable solution to a umbral dot because electricity and magnetism are inherently intertwined and symmetrical. But more research needs to be conducted because we can't say anything for sure, and these are very new subjects in study. We can only say that discoveries are always the result of human curiosity.